Every automation tool you have ever used keeps its history in somebody else's database. This one keeps it on Bitcoin. Watch 4 strangers close a contract with no accounts, no server, and no trust. This is BitClaw. There is no backend holding your data. The application's own modules are published as Bitcoin transactions. The business record's live on-chain, and the server only proxies reads. Top left is Alice, the owner. She is drawing the process on a mind map. First node, the contract document. She types the text and the signatures panel hashes it with SHA-256. That hash, not the file, is what people sign. Then she names who may sign Bob, Carol, and Dave, and how many signatures are needed. 2. The document itself never leaves her browser. The next node is the gate. It waits for signatures on that hash, and it does not count records. It verifies every signature cryptographically, a forged one, or a perfectly valid one from somebody who is not on the list, moves nothing. Then, the decision. The same 3 people, a quorum of 2, approve or reject. After it, the payout, 25,000 satoshis to the contractor, and a notification that fans out to 1 message per recipient, 4 nodes. That is the entire process. Now compile, but first simulate. It walks these exact steps with 0 broadcasts, so you can check the shape before spending anything. The table underneath is what will really happen. 9 steps, who pays for each one, and what it costs. Fractions of a cent per step. Compiled into her own outbox, 9 cards. The first one is active. Everything after it is blocked and waiting. Nothing exists on the blockchain yet. A compile writes drafts, and every single draft still needs her to press broadcast. While she waits, look at the outbox itself. It is a state machine, not a send button. Drafts, approvals, sequencing, a permanent log. A policy screen can let some of it fire on its own. And in Pro mode, every module has a source button that fetches its code straight from the chain. Audit the app you are using. Bob, top right. Carol, bottom left. Each of them pastes the hash and signs it with her own key. Notice that neither one ever opens Alice's board. Signatures anchor to the hash globally, so a signer needs the document, not permission to your workspace. 2 signatures land. Alice's tab is pulling the chain and the gate closes itself. Nobody clicked approve. Dave has not signed, and he never will. 2 of 3 was the rule, so the rule is satisfied. The assignments unblock. 1 transaction per group member, each anchored to that member's own address, so they find it by scanning themselves. Nothing is pushed to them. There is no notification server to trust, and none to break. Worth saying out loud, nobody has to draw this by hand. There are 23 ready-made processes in the template gallery, and one of them is literally called Document Approval, 2 of 3, and the catalog behind it holds over 100 smart contracts, any of which can become a step in a diagram like this one. Bob opens his assignment and votes. This ballot is the vote. Choosing an option signs a transaction that carries that choice. Carol does the same. Both approve. 2 signed votes on a public ledger from 2 independent wallets that nobody can quietly edit afterwards. Quorum met. Alice's payout card unblocks on its own, and she broadcasts it. 25,000 satoshis, a plain payment, straight to the contractor. Dave stayed silent through the whole run. The process finished anyway. That is what a quorum is for. One thing this recording does the manual way on purpose. The same process can be published as a headless workflow, and then a runner executes it for you. But a runner that can spend money is a risk, so it gets fenced in. Payouts can go through a covenant contract, where the Bitcoin script itself enforces which recipients and how much are allowed. The robot cannot pay the wrong address, not because it promised, but because the script rejects it. And you stop it with money instead of a support ticket. Every background roll holds a single Satoshi. Spend that one coin from any device and the roll dies. Here, the notifications go out. One transaction per recipient. There is a WebSocket relay that makes all of this feel instant, but it is only an accelerator. The blockchain stays the source of truth. Finally, the run panel. It reads the finished run back off the chain, step by step, and colors the diagram. This is not a log that Alice owns. Every participant reads the same run from the same ledger, and every step is a transaction you can open in any Explorer. 2 of 3 signed, 2 of 3 approved, paid. 4 bare Bitcoin addresses, no accounts, no database, and about 1 cent in fees. The process is the transactions. This is BitClaw.